What's going on, guys? So in a recent video, I attempted the Fireball Tool Challenge, where you make 2 square weldments in under 30 minutes. That didn't go so well, and I epically failed that challenge. Now, to better set myself up for success for a second attempt at the challenge, I first modified my table. Now, the video I'll put here, and in that video, I put all thread studs underneath the top plate of my table itself, made it adjustable, and then I fine-tuned the flatness. The second thing that I'm gonna do is I'm going to perform a mock kind of test where I don't do any welding, but I attempt to set the pieces up in the allotted time frame, and then I'll check them. It's really just gonna allow for me to better see little tasks and things that need to be done efficiently in that process and make adjustments prior to attempting the Fireball Tool Challenge for the second go round. Let's get to it. Here are the pieces from the last video. So I actually set them up and marked my first set as A and my second set as B's. I did have to do a little bit of grinding on a few of the pieces on both sets to get them to the 20 1/4 and then the 20 inch. On the 20 inchers, I actually went under a hair. So these two are 1/16 under. And on this side, this one's 1/16 under, and this is 1/32 under. That's gonna allow me to be under the 20 dimension, which is specified on the print. It's +0 and -1/16. So on these 16th lengths, as long as there's a hair of a gap in here, it's gonna result in that 20 dimension being met. I also have my 30-minute countdown timer ready to go. And I have my modified table with this side being the flat side ready to go as well. So let's get into it. So I'm gonna set up my section A first. So 20 1/16, 20 1/4. So that's gonna be a side piece. And 20 1/4, 20 1/32. Okay. Let's hit the countdown timer. I should have hit it before I put the pieces on, but that's okay. Yep, so 3, 2, 1, and we're live. Okay. So I'm gonna set these up. Now remember, I can use my table now. It's pretty flat. I'm also going to use kind of the traditional square magnets to get everything set up initially. Man, it sure would be nice to be able to use the edge of my table to set up the squareness of it. That would require some stops on the outside, removable stops. Uh-oh, I forgot to start my GoPro up here. I think what I could do, man, let's talk about it after the fact, but I think I could do some removable tabs like the Fireball square on the side of my table to serve as a guard to kind of butt everything up to. Okay, let's get the clamps. I'm going to use a 3-2-1 block to clamp across the weld joint. just so it flattens both sides of the joint together onto a flat plane. I don't know if that's the best thing to do, but I'm doing it. Let's make sure my GoPro's working here. All right, I think we're good. Got a splinter or a metal shaving. Ow. That was a deep one. Maybe I should wear gloves during the challenge. All right. The problem I see here is we have our last one here that I'm not going to be able to get a clamp to. However, it's not, there's no gap underneath it. Absolutely no gap. So I think that'll work. Now let's go through and measure this with our tape measure. Obviously, it's not going to be the most accurate. I have 3 tape measures, and we're going to go off of the one dimension and not just use the wobbly stop here. So in the 20-inch direction, so that negative 30-second got consumed, and it's spot on, actually. It's right on. So this one, this side with the 16th actually looks like it's a 30-second off, but it's not a 16th out, which would satisfy the requirements. Let's try the 20 1/4. Make sure we're straight. Okay, so it is a 16th short. Maybe a hair over a 16th short. 20 1/4. This one's a hair over a 16th short as well, which is biasing towards the good side. So I think we'd be ready to go on this one. So let me grab my gun. Grab my gun. What I would do is tack the top corner and the bottom corner on each of these edges. And then I'd probably go through and tack this inside corner. Now typically I would do this side and then I'd do the opposite side, but thinking of the mechanism and how it would actually pull in the same direction and bring this out of square, I'm probably just gonna do a circle around. Go ahead and leave a comment what you think my weld sequencing should be for this part. And that way, if I need to change anything for the actual
non-mock-up, the test or the challenge that I'm gonna take, I'll get it addressed in this video. Zzz, zzz. Check everything, we're all good. Tighten down. Zzz, zzz. Zzz, zzz. Check everything, we're all tightened down. I probably will start with the side. When I actually do it, I should have started with the side that has no clamp on it. Man, I really wish there was a way to clamp that. Man, that metal splinter hurts. Yeah, I need some way to clamp the center, this joint. We'll figure that out. Maybe I'll weld a clamp. I might weld a C-clamp to it. Now remember, I have to do that in the middle of the video. So let's weld this last one. Zzz, zzz. Now the inside corner. Zzz, zzz, zzz. Now I need to make sure my blocks are not covering that inside corner when I do it. Got to remember that. Okay. Now, theoretically, I need to tack the other side, but what I'll do is I'll undo these. I'm just going to act like I undid them. Flip it back around. So imagine I flipped it, and then now I'm going to tack the inside corners. Zzz, 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 zzz. And then I need to weld, I think, the faces. So what I should have done on the second round, we'll do this when I do the actual test. On the second round, I needed to move these clamps over. So when I flip it and it's tacked together, it's not going to fall apart. I need to move them to either one side or the other so I can get to the weld joints. So imagine the clamps aren't over. Okay, so I just have the faces, and let's weld the outside seam as well. Okay, so take the clamps off, taking them off, taking them off. I flipped it, now I have to do the other. So now we got both top and bottom seams and outside seams welded up. So here's where I would do the inside seam. Now my natural inclination to get a nice weld would be to unclamp it, stand it up to where I'm doing essentially a fillet weld flat. Because the clamp kind of helps everything, I think I'll leave it in. Yeah, I'll leave it clamped up. So, zzz, zzz, zzz. We are halfway through, so at this point, no checking. We're somewhat welded up. So this should be a solid piece. Hold up. Okay, so at that point, let's put these back. I think we're gonna use this one as a jig. So put these back where they were. And the only difference so let's do a quick flatness check. So and we already did the dimensional check, but I'll do that real quick. 20/4. Looking good. Okay, so if everything's good on that first round, I'm gonna go ahead and I'll put a brand new Nico flap disc on it. So I'll flatten this side completely flat. The welds on the bottom will make it a little bit wonky, but itself should be flat, right? Yes. What do you think? Should I grind the bottom? Make sure it sits flat on my table? Yep, so we're gonna flip it over. We're gonna just barely hit the tops of the bottom welds, just to make sure there's no big, huge edges. I won't do that to you anymore. You get the voice sound effects. Just real quick on these bottom welds. Okay, flip it over, have the completely flat portion of these, flat side of these on the top. And we're gonna do a 20.25, 20.25, 20.16, 20.16. Get it all lined up here perfectly. 20 on the dot, 20 on the dot, 20 and a quarter, 20 and a quarter. Okay, so it seems like they're cut just right and they're sitting when I butt them up against all of it, the -1/16 under on that one dimension and being right at 20 and a quarter works well. So let's do something similar as we did with the first one. So we'll clamp these over the sides. Okay, we'll crank these down. No gaps. Everything looks good. We'll do another check. Spot on 20. Spot on 20. Spot on 20 quarter. Spot on 20 and a quarter. Man, being able to use the table big time. Now we haven't really checked flatness. We'll use the string method just to make sure the flatness is good at the end of it, but we can't really do that in the middle of it to check it, so we're just gonna have to trust in the system. So I do this. Okay, so it appears this side is pushing up a little bit right here. So we're gonna have to be able to clamp that corner down. I think what I might do, do I have anything at the center of my table? Okay, let's finish this out. We'll talk about it later. Okay, measured, all looks good. Let's weld these, tack these outside corners. Zzz, 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 zzz. Okay, inside corners. Zzz, 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 zzz. Zzz, 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 zzz. Okay, outside corners, inside corners are all tacked up. Let's just move the clamps. Okay, move the clamp so I can do the seam. Okay, I want to get this flipped over as fast as possible before those cool all the way. So I pick it up, I flip it, put these back on. Do the seams again. Okay, all the seams are good. Let's do the outside corner. I think because of how rushed this is going to be, my welds are going to look like junk, but weld quality really wasn't something that the drawing addressed, so we'll just make it to the print. Okay, inside corner. Okay, inside, seams, outside, everything's checked. We're good? Okay. Unclamp. Okay, we have 2 squares. Now, let's use a different tape measure. Here under 20, here under 20, 20 and a quarter, 20 and a quarter. Now, we're going to use our string test. Remember, we're supposed to be able to check flatness and dimension within the time frame. Where'd I put my string? Dang it. Well, I had a dedicated string for this. We'll just... Oh, almost forgot. Got to grind it. One side, remember? That's what the drawing says. New flap disc, so it's super quick. And I will have a corded angle grinder on the side just to be sure that my 2 batteries don't fail me during the test. Two minutes. Again, this is going to be where I'm going to need to make sure I have a clamp on that opposite corner. Man, they're actually pretty close. I mean, they're clamped down to the table. I might need to use fishing line. So they're pushing on each other the right direction and they're just barely touching. So the one is pushing on the other one pretty good, but it could just be to the diameter of this string here. So I think I need to use fishing line. Okay, we got 7 seconds. So in reality, I would have had to take this one off and redo the string. 30 minutes. So So it's doable. Let's sit down and talk through what it's going to take. Okay, so there's hope. We didn't quite meet the 30 minutes with the mock-up, but I think it just goes to show that there's opportunity that with this table, I think we can. Given I didn't actually check all the flatness and dimensions on a final product. So we'll see there. I think the goal is going to be to move quickly in the test itself to make sure we meet the 30-minute timer, and then we'll check everything after the fact. And if it's out, it's out. We'll just chalk that up to user skill level, as well as not having a freaking machine perfect flat and usable table. Couple notes from what I figured out during my mock-up. I didn't check squareness of the inside joints or the outside joints with a big square here. So looking at it just now, it is a little bit out of square. So I will need to check the diagonals in the video and make sure during the welding process that we don't get out of square. I need to look at the print, not sure what the requirements are on square. There was flatness and dimensions, so maybe squareness isn't talked about. I'll go look. The other thing is the string seems to be a little over 1/8 inch thickness here. Yeah, I mean, it's thicker than a 1/16, which they're gonna be pushing against each other. What I'm gonna do is use fishing line, so it's real fine filament, and we're gonna be able to get a little bit better on the flatness check. And then during the building process, the first big point was I need a clamp at the center of my table that I can push down on that fourth corner. So I think what I'm gonna probably end up doing is either drilling a hole at the center of my table to allow for an F clamp to slide. So I'll take this side off. Uh-oh, gonna have to grind that down. So I'll take this off of an F clamp, or maybe I'll just make it large enough to where this end will slide down in. That's what we'll do. We'll make it large enough for that end to slide down in it. And I think if it's at the center of the table, it's gonna be able to reach out and grab that spot there. There's no threaded stud at the center, so we should be good. What I'll do is I'll actually mark this corner with a Sharpie. So whenever I go to cut a hole out on this table to get that last clamp in there, we should be good for the spacing. Additionally, I think I might actually weld a nut on the side of my table to serve as a stop. So what I'll do is I'll check the threads on my Fireball tool, stop threads, and I'll probably mimic whatever this is on the side of my table. And what that's gonna allow me to do is use these Fireball tool stops to just thread to the side of my table like that, and it'll be a stop, so I can quickly slide the parts up against it. Essentially similar to what the Fireball tool table does, with it being able to put those pegs in the holes and just slide up to a stop. We'll see, it's gonna be tough. We're gonna have to get it on point and be super quick at everything. So help me out, leave me some recommendations on procedures, on weld sequencing, on anything that I could improve with this kind of setup and process in order to meet the 30-minute time with my plate steel table. And if I can't get this, man, I'm gonna be taking a hard look at a fabrication style table where you have laser cut holes, very precise, to be able to set something up flat. I'm only a hobbyist, so to get a table like that is not really warranted at this point, but if I save up for a while, maybe in a year or two, I could get one. Anyways, let me know what you think. Peace.